Hello everyone and welcome back again to yet another problem from LeetCode. First, missing positive. So this is a very interesting problem which says given an unsorted integer array nums, return the smallest positive integer that is not present in nums. You must implement the algorithm that runs in O of n time complexity and uses O of 1 auxiliary space. So problem is pretty simple. We are provided an unsorted array and we need to return the smallest positive integer not present in nums. So provided this array, the smallest positive integer is 3 as seen. So within this array, the number is 2 and for this array, the number is 1. So one thing it can be is you can go ahead and create a hash map. So let me write one by one approaches. It's a very good problem if you're looking around it. So approaches. So you have number one solution for it. Let me expand this. Yep. So number one, you can go ahead and directly use a hash map or which will but use a O of n space complexity. So that's not what you want. Avoiding space and considering only time, you can sort the elements and find out whatsoever it is. But it will take O of n log n time complexity, which is still we don't want that. So we want some certain solution where we have a time complexity of O of n and space complexity of O of 1. So let's consider the hash map solution. The only problem here is we take O of n space complexity. So could we remove that? It seems that yes, we could do that. How? That is a question. So using a hash map as an external data structure is causing us an auxiliary space. So what if we use only the given data structure, which is an array, which they have provided. So int nums. So the only hash map does is it takes a count or it takes a visibility check, visited check, which means if number is in map, then it is visited, else not. So this is what the map does. Can we mimic the operation? Okay, let me maximize this one. Okay, now it's clear. So can we mimic this operation? Can we mark, let's take an array saying 3, 4, minus 1, 1, and let me say that can we mark this array with itself so that we can ensure that we have visited most of the elements. Not all, at least target for most of the elements as of now. So it says 3. The first element is 3. So how to mark 3 as visited? How to see we visited 3? So we can do one thing. We can just take 3 and go ahead and mark the third index as with some pointer. So as of now, I'm just taking a star so that we have a visited mark. So we have 4. Then we can take the fourth index and we can mark it as visited. Then we have minus 1. Minus 1 is not a valid index, so we are not considering minus 1. So let me write it also. Note, minus 1 is not valid index, so we do not mark it. And here ultimately it is 1, so mark 1 as well. When I'm saying 1, then I'm saying to mark the position. So first position I'm marking. So it seems like, let me copy it step by step, which will become in a way like this. So considering 3, we have marked this position, but this is here. Considering 4, we have marked, we already marked this position, so we have marked this as well. Considering -1, which is none, and considering, let me copy this then, and as it is, this and this as it is, and considering 1, because 1 is the last element, we have to mark first position as well. So this is how we have obtained the ultimate result. Now we need to check iterate. Now what we do is iterate the array, or iterate the range from 1 to n, where n is the size of an array, so that we see any non-occurring position. So we iterate 1, we find out that hey, 1 is negative, it is visited, as 3 is visited. 2, unfortunately 2 is not visited, so we take 2 and return the 2. Hence 2 is the answer. Now here are corner cases. I mentioned that note -1 is not a valid index. So we need to deal with the negative characters. Not only that, we also need to deal with 0 characters. So deal with negative and 0 element. So what I'll do is, first of all, I'll mark 0 element with a negative number, so that we do not need to worry about both negative numbers and 0 numbers. So int I is equal to 0, quickly iterating the array by nums.length I plus plus, and within each number, if it is nums of I is less than or equal to 0, so less than or equal to, it carries out dealing with negative and 0, I will mark nums of I to maximum number. So what that maximum would be? Think for yourself what the maximum should be for now. Have you got the answer? The answer would be maximum needs to be nums plus 1. In any scenario, if you find num uh, array, the length of array, the number won't even exceed the length of array. Let that sink in for a while, because even if you have 1, 2, 3, 4 till n, n plus 1 would be your desired answer. And let's suppose you have missed any of the numbers from 1 to n, your desired answer would be less than n. So n would be the maximum number, but for now I'm keeping it up to the constraint level, which is 10 to power 5. So 10 with 5 zeros behind it, and just for sake of security, I'm adding 1 to it. So that maximum is directly exclusive. Not equal to, it's equal to, that's the reason I'm adding 1 to it. It's totally exclusive. So now we have dealt with negative and 0 index. We can get going to mark the numbers. So mark visited. So I'll take elements one by one. Int element in nums. So I'll say if, okay, what's wrong? So I'll first of all take position is equal to math.abs of element -1. Why -1? Because obviously within Java, index starts with 0 and not 1. So if you're getting 1, we need to mark 0. And that is what we will handle further as well. Index issues and nothing much. So if position is valid, that means it's greater than or equal to 0, and also position is less than nums.length. And obviously we need to check if nums of position is less than 0. Sorry, if it is greater than 0, that means it's a positive number. We need to mark it as negative. So marking negative means nums of position multiply equal to -1. Nothing much, nothing fancy. We took one number, we got a position, we marked it. That's the thing we are doing. We took a number, got the position, and marked it. Why if condition? Yeah, this is an additional check I've added because it might happen that the element itself is negative or it is exceeding the index. So it might happen that element is, let's suppose 99, and you minus 99 minus 1, 98. But guess what? The length of an array is 4. So 98 would exceed, and this would cause a array index out of bound issue. That's the reason this is the check for index. So you can just extract this method as check index or is valid index. So now once the loop is over, we are sure that each and every each valid index is marked. Now we can go ahead and go to our range. As we have mentioned, iterate the range from 1 to n. Let me copy this so that we are on the same page and things are super clear. I from 0 to I is less than n I plus plus. Yeah, it's 1 to n, but as you know, index issues, 1 is not the starting of array, 0 is the starting of array, and hence we are doing this. You can use 1 as well, but you need to change the underlying logic. So I'm saying if the underlying element is not visited, in this case visited is marked with a negative number. If it is not visited, this is the lowest position. So if nums of I is greater than 0, this is a valid non-encountered number, or let's say position for that factor, because we are marking position based on position, right? So we took position, we marked it. So now we need to return position plus 1. Why plus 1? You are sure of it because we we start array elements from 0. That's the reason we take -1, and returning 0 is not possible. So 0 plus 1 is 1, and that's how it is. So ultimately, if we didn't found anything, so we return nums dot length plus 1. Sure. Why we have used nums dot length plus 1? Any idea? So this comes out to be like, let's suppose we have encounter 3, 4, 5. We have 5 elements, and as each of them are present within an array, each would get a negative assignment. This would be the end of array, sorry, end of these operations. And as you can see, each and every element is negative. This condition won't even be true, and hence nothing could be returned from this loop. And ultimately, the next number is automatically the greater one. So 6 is the greatest, size is 5, which means 6 is equal to array length plus 1. That's what we are returning over here, is it? Make sense? So let's try to run this. So we have few errors, which is compiler errors, that's fine. And we have a position as well. Position is not defined because we have took I as a position variable. So let's compile it now. So it has accepted few of the test cases. Let's submit it so that we can check over the rest of test cases as well. So yeah, it has passed the test cases, and that's it. This is yet another very good problem, and yet another I'm saying again that do not rely upon the score, even though it is saying 98% beat. But if you can see the 2% which is far ahead of this problem, we are using a new space over here. So do not rely upon the solution. Within the solution they have used extra space. That is not what we want. We want without any extra space, which is this solution. Oh, they have used swap over here. It's interesting. I insist you to go ahead and check this solution as well. I personally find out that marking an array and using the internal array as a map or as a frequency or a visit table much more interesting. That's the reason I have went ahead with this. Your option can be differ from mine. So do let me know what your thought is and how would you like to approach this, or what kind of solution do you find worthy apart from this, or is it like do you want to stick to the previous two solutions? Do let me know down below and I'll see you in the next one.